Welcome to the deep dive. Today, we are diving into the world where AI and quantum computing are kind of colliding.
Yeah.
And we're going to be pulling from AI meets quantum synergies and future applications. And
Yeah.
I think you're listening because you want to understand how these two really groundbreaking technologies are going to reshape the world.
Absolutely.
So we'll be talking about everything from drug discovery and materials to cryptography and finance and even potentially revolutionizing how we understand consciousness itself.
Yeah. I think this is an area where we're really seeing groundbreaking advancements um, happening at an unprecedented pace.
Yeah.
And what's so fascinating about this is that it's not just about adding the power of AI to the power of quantum.
Right.
It's really about the synergy between them,
Yeah.
how they amplify each other's strengths and unlock possibilities that we could only dream of before.
Yeah, it's not just 1 + 1 = 2. It's like
Yeah.
you're putting together ingredients that react to
Exactly.
create something totally new and far more potent than the sum of their parts.
And one of the most exciting aspects of this is how quantum computing addresses one of AI's biggest bottlenecks,
Okay.
data processing. So AI algorithms, especially those used in machine learning, are incredibly data hungry.
Right.
The more data they have to train on, the more accurate and powerful they become. But processing these massive data sets can take an enormous amount of time and computational power, even for the most advanced classical computers.
It's like trying to drink from a fire hose.
Like
You
that.
have all this data coming in, but you can only process a tiny fraction of it at a time.
Exactly. And this is where quantum computing comes in.
Okay.
With its ability to perform computations in parallel, quantum computing can process information exponentially faster than classical computers.
Yeah.
It's like having thousands of processors working simultaneously on the same problem.
So you're giving AI a massive turbocharger, allowing it to crunch through these huge data sets in a fraction of the time.
Yeah,
But it sounds like quantum computing offers more than just raw speed.
right. Our source material also talks about this thing called the Quantum Approximate Optimization Algorithm, or QAOA.
Yes, QAOA is a really intriguing development. It's not just about finding a good solution to a problem.
Okay.
It's about finding the best possible solution. Think of it like trying to optimize a complex delivery route with hundreds of stops.
Yeah.
Classical algorithms might find a decent route, but QAOA could potentially find the absolute shortest and most efficient route, saving you time, fuel, and money.
So you're not settling for good enough,
Yeah,
but actually finding the optimal outcome?
absolutely.
That's a game changer for AI, especially in areas like logistics, finance, and even scientific research. Speaking of optimization, our source material also mentioned QAOA being used to accelerate the training of neural networks, even helping them escape something called local minima. For those of us who aren't deep into machine learning,
Sure.
can you explain what that means?
Yeah, so you see, in machine learning, algorithms can sometimes get stuck in a suboptimal solution.
Imagine you're hiking in a mountain range
Mm.
and trying to find the lowest valley. A classical algorithm might get stuck in a small dip, thinking it's the lowest point. But quantum computing, with its ability to explore multiple paths simultaneously, could help the AI jump out of that local minimum
Mm.
and find the true lowest valley, which represents the best solution.
So it's about pushing AI beyond its current limitations, helping it find solutions that might be hidden from classical algorithms.
Exactly.
This is really fascinating stuff. And this brings us to another exciting area mentioned in our report, quantum machine learning, or QML. Looks like there are two main approaches here, hybrid and quantum native. What's the difference between the two?
So hybrid QML is like a partnership between classical and quantum computing. We're essentially using quantum computers to assist classical computers with specific tasks where they excel. One example is evaluating quantum kernels, which are functions that map data in ways classical computers can't. This allows AI algorithms to uncover hidden patterns and relationships that might otherwise be missed. It's like giving AI a new set of lenses to see the world through revealing insights that were previously invisible.
That's an incredible way to put it. And what about quantum native algorithms? Are those being used in any practical applications yet?
Quantum native algorithms are designed to run entirely on quantum computers,
Yeah.
harnessing their full potential. They're still in the early stages of development,
Okay.
but they hold immense promise for revolutionizing AI. One exciting development in this area is variational quantum algorithms, or VQAs. These algorithms are designed to work on the noisy quantum computers we have today, making them a practical step towards realizing the potential of quantum-enhanced AI.
So we're already seeing how AI and quantum computing can kind of like enhance each other. But I'm curious about the practical applications of this. Are we talking about things that are going to impact our lives, in the near future, or is this mostly theoretical?
The exciting thing is that a lot of these applications are already starting to move from the realm of theory into real-world implementations. One area where we're seeing significant progress is in the natural sciences,
Okay.
particularly drug discovery and material science.
Those fields seem ripe for disruption, especially as the problems they're trying to solve get more and more complex.
Absolutely.
Can you give us some concrete examples of how AI and quantum computing are being used in these areas?
Absolutely. So imagine a world where new drugs can be designed and tested in a fraction of the time it takes today, where treatments can be tailored to your individual genetic makeup, and where we can create materials with properties we never thought possible. These are just some of the potential applications that are being explored right now.
That sounds incredible, but how exactly does quantum computing play into all of this?
One of the key challenges in drug discovery is simulating the interactions between molecules, especially complex biological molecules like proteins. Classical computers really struggle with these kinds of simulations because the number of possible interactions grows exponentially with the size of the molecules. Quantum computers, however, are uniquely suited for this task. They can leverage the principles of quantum mechanics to simulate these interactions with incredible accuracy and speed.
So instead of spending years in the lab trying out different combinations of molecules, we could use quantum computers to design and test new drugs virtually,
Right.
significantly accelerating the entire process.
That's the idea, and it goes beyond drug discovery. Quantum simulations can also be used to design new materials with specific properties, like strength, conductivity, or heat resistance. This could lead to breakthroughs in everything from aerospace engineering to renewable energy.
It's amazing to think that we're on the cusp of being able to design materials at the atomic level, creating substances with properties that were previously unimaginable. But our source material also mentions the impact of quantum computing on cryptography, which is an area that's always kind of fascinated me. How is this technology going to change the way we protect our data and secure our communications?
Cryptography is a perfect example of how quantum computing presents both challenges and opportunities.
Okay.
On one hand, quantum computers pose a serious threat to many of the encryption methods we use today. The algorithms that underpin these methods are based on mathematical problems that are difficult for classical computers to solve. But quantum computers could potentially crack them with ease.
So we're talking about potentially being able to break the codes that protect everything, like our online banking, our emails, even sensitive government communications.
It's a real concern, and it's driving a lot of research into new encryption methods that are resistant to quantum attacks. But on a flip side, quantum computing also enables something called quantum cryptography, which is theoretically unbreakable.
So it's kind of a cryptographic arms race. Quantum computers break the old codes, but also provide the keys to new, more secure ones.
Exactly. Quantum cryptography relies on the principles of quantum mechanics to create encryption keys that are impossible to intercept or copy without being detected. It's like having a lock that changes its shape every time someone tries to pick it, making it virtually impossible to break.
That's a powerful analogy. Speaking of areas that rely heavily on secure communications and complex algorithms, our source material also delves into the potential impact of AI and quantum computing on the world of finance. What kind of changes are we talking about here?
Well, the financial industry is always looking for ways to gain an edge.
Right.
Whether it's predicting market movements, managing risk, or optimizing investments, AI is already playing a significant role in these areas. But quantum computing could take it to a whole new level.
I can imagine our source material mentions things like improved risk analysis, portfolio optimization that can outperform anything we have today, and fraud detection that's light years ahead. Sounds like a financial revolution is brewing.
It does, doesn't it? Imagine being able to accurately predict market fluctuations, optimize your investments with quantum algorithms, and detect fraudulent transactions in real time. These are just some of the potential applications that are being explored.
It's both exciting and a bit daunting to think about the potential impact on the financial markets. What about the broader economic implications?
That's an important question. Quantum computing, coupled with AI, could lead to more efficient markets, better risk management, and potentially even more stable economies. But it's crucial to ensure that access to this technology is widespread and doesn't contribute to existing inequalities.
It seems like every facet of this topic has this duality to it. We've talked about the potential for groundbreaking advancements, but there are also these significant challenges to address.
Absolutely. We're still in the early stages of this technological revolution.
Yeah.
And it's crucial to proceed thoughtfully and responsibly. One of the biggest challenges is developing scalable quantum hardware. The quantum computers we have today are still relatively small and prone to errors. We need to make significant progress in building larger, more stable quantum computers before we can fully unlock their potential.
It sounds like building these quantum computers is a monumental task.
It certainly is. It requires pushing the boundaries of physics engineering and computer science. But researchers around the world are making steady progress. Another challenge is developing new algorithms that are specifically designed to leverage the unique capabilities of quantum computers.
Right.
We can't just take existing classical algorithms and run them on a quantum computer. We need entirely new approaches to problem solving that can exploit the power of quantum mechanics.
So it's not just about building the hardware, it's about developing the software and the theoretical frameworks that will allow us to use these machines effectively. And then, of course, there's the human element. We need to make sure that these technologies are used for good, that they benefit society as a whole, and that we don't create any unintended consequences. It's a lot to consider. But it's clear that we're on the verge of something truly transformative. So we've covered a lot of ground in this deep dive, from the fundamental principles of quantum computing to the potential applications in various fields. What are some key takeaways you think our listeners should walk away with?
I think the most important takeaway is that this convergence of AI and quantum computing is not just hype. It's a reality that's unfolding right before our eyes. And the implications are profound, touching everything from healthcare and finance to materials science and cryptography.
It's been really fascinating to explore how these two seemingly disparate fields are coming together to create something entirely new and far more powerful than the sum of their parts.
And remember, it's not just a one-way street. AI is playing a crucial role in advancing quantum computing, just as quantum computing is accelerating AI.
Yeah, that's a really crucial point. They're not competing with each other. They're complementing each other, pushing each other forward. But as we've discussed, it's not all smooth sailing. There are significant challenges to overcome, from building scalable quantum hardware to developing robust quantum algorithms and addressing the ethical implications.
Absolutely. We need to be mindful of the potential risks as we navigate this new technological landscape. But I believe the potential benefits are so great that we have a moral imperative to pursue this research responsibly and thoughtfully.
Our source material certainly left me with a sense of awe and cautious optimism. It's mind-blowing to think about the possibilities. But we also have this responsibility to ensure that these technologies are used for the betterment of humanity. But let's end this deep dive on a slightly more philosophical note. Our discussion about the potential of quantum computing to simulate complex systems got me thinking. If we can eventually simulate the universe at its most fundamental level, could we also simulate consciousness?
Now, that's a profound question. It's one that philosophers and scientists have pondered for centuries. And with the advent of quantum computing, it's starting to feel like a question we might actually be able to answer someday.
Imagine the implications. If we could create machines that are not just intelligent, but also conscious, how would that change our understanding of ourselves and our place in the universe? It's a question that raises more questions than answers, but that's the beauty of it.
Right.
It forces us to confront these fundamental mysteries of existence.
And it highlights the importance of continued exploration and open-minded inquiry. As we delve deeper into the realms of AI and quantum computing, we're bound to encounter more questions like this, questions that challenge our assumptions and expand our understanding of what's possible.
So to our listener, we leave you with this thought. What possibilities spark your imagination when you think about this convergence of AI and quantum computing? What questions do you still have? And how do you think these technologies will shape the future? Keep exploring, keep questioning, and most importantly, keep learning.
It's a journey that's just beginning, and the destination is still unknown. But one thing is certain, it's going to be an incredible ride.
Thank you for joining us on this deep dive into the world of AI and quantum computing. Until next time, keep those minds curious.